So today we're going over section 2.6, prove angle pair relationships. All right, a flowchart and paragraph proof. A flowchart or flow proof uses boxes and arrows to show the flow of a logical argument, and a paragraph proof represents the statements and reasons of a proof as a sentence in a paragraph. For the first one, it's kind of here, you write a statement, right? In the arrow, the reason, and then into a new statement. That's how that one works. Now, a paragraph is just for, it's kind of like English. You just write a paragraph to show what's going on. Before I forget, guys, we will not write flowcharts or paragraphs proofs. Just note what they are. So I'm just going to write it in the top. All right, so the theorem is 2.3, right angles congruence theorem. Guys, don't worry about the number of the theorem. Just remember right angle congruence theorem. Know the name and what it says and what it's for. Don't worry about the number. So all right angles are congruent. That means if you have an angle like this, that's right angle, and another one that's like this, they're congruent because they're both 90 degrees. Good job. Now the flow chart or flow proof. Again, this is an example of what it looks like. We're not going to have to do it in class. We're going to... So this is an example, proving right angles congruence theorem. This is just going to prove what we just said in the last slide. So use the given flowchart proof to write a 2-column proof on the right angles. Again, so you guys have an idea, they give you, again, the same steps, the given and what you have to prove. They go from the right angle, that's the given, that's the reason as I showed you in the other one. Then they give you another statement with another reason, then another statement with a third reason, another statement with a fourth reason. Now you can actually write that as a statement the same way we've been doing it and a reason. You can write the given, so angle 1 and angle 2 are right angles, and that we write as the given. Then the second statement, which is this one, is the measure of angle 1 equals 90, and the measure of angle 2 equals 90. That is a definition of a right angle. Yeah. Now you're going to write step 3 and 4. This is step 3. This is step 4. You can write it in the same way as a column, as I was doing on the side. But it's just to show you that they correlate and they work together. All right, this is example 2, right angles congruence theorems. All right angles are congruent, so they tell us the given. Angle 1 and angle 2 are right angles, and then we're going to prove it. Angle 1 is congruent to angle 2. So they tell us the statements. Angle 1 and angle 2 are right angles.
That's given.
That is given. Now, measure of angle 1 equals 90, and measure of angle 2, yes, the definition of right angles.
C is transitive. Yeah.
Now, C is substitution, because you guys see there 90 equals 90. We could put it in. And the last one is a definition of congruent angles. Yeah. Please write it in.
Your handwriting is so nice.
Thank you. Now, guys, I want you to notice, now that we proved that this is correct and we can do it the long way, I want you guys to realize that because we proved the theorem we had just gone over, which was the right angle of congruence theorem, we can just go from step 1 straight to the last step by saying that Angle 1 and angle 2 are right angles. That's a given. And we can just go straight and say that the angle 1 is congruent to angle 2 because of the right angles congruence theorem. Now that we proved it, we can actually skip steps B and C and just go from A to D. So this is theorem 2.4. Again, you don't have to worry about the number. Just know what it is and what it stands for. So congruent supplement theorem is if two angles are supplements to the same angle or to congruent angles, then they are congruent. So if angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 and angle 3 are congruent. Let's say that. So 1 and 2 are supplementary. 3 and 2 are supplementary. If you guys notice, 2 is the same angle and a supplementary angle, it's always equal to 180. So because it's equal always to 180, when we subtract 180, whatever angle 2 is, we're going to get angle 1 and angle 3. That's why the both angles are supplementary, and that's why the angle 1 and angle 3 are congruent. So this is an example 3, and they're telling us that angle 1 and angle 2 are supplementary. Angle 3 and angle 2 are also supplementary. So I'm going to mark that down. 1 and 2 are supplementary, and in a different color, 3 and 2 as well are supplementary. They want us to prove that angle 1 and angle 3 are congruent. So the first statement, again, is just a given. The second one, they're telling us that the measure of angle 1 and the measure of angle 2 equals 180. Yes. And the measure of angle 3 plus measure of angle 2 is 180. That is the definition of supplementary. I'm just going to leave it there because I ran out of space to write. Now for step 3, they're telling us that the measure of angle 1 and the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. So you can see, guys, 180 equals 180. So all it did was to substitute those in. Now for step 4, we have the measure of angle 1 equals the measure of angle 3. The way we got there was by subtracting m minus 2 on both sides, and they cancel out. Because they cancel out, that is a subtraction. The property of equality, sorry. And lastly, we get to the angle 1 is congruent to angle 3. That is the definition of congruent angles. Again, you can go from step 1 all the way to step 5 with the theorem that we just learned. We just proved the theorem, so now we can just go straight from 1 to 5. So, theorem 2.5, again, don't worry about the number, just know what it does and what it is. It's a congruent complement theorem. So if two angles are complements to the same angle or to congruent angles, then they are congruent. So if angle 1 and angle 2 are complementary, so these two, then angle 1 and angle 3, this one and angle 2 are complementary, then angle 1 and angle 3 are equal. They're congruent. It's the same as the supplements theorem that we went over a few slides ago. Just instead of 180, it's 90 because it's complementary. Now this is postulate 2.8. Again, don't worry about the number. So linear pair postulate. So if two angles form a linear pair, then they are supplementary. So if angle 1 and angle 2 form a linear pair, so angle 1 and angle 2 are supplementary, and the measure of angle 1 plus the measure of angle 2 equals 180. You guys have seen these already. So the addition of these two angles is going to equal 180 because it's a straight line. Vertical angles, the definition. So this is basically how they're formed. So two angles such that the sides of one angle are opposite raised to the sides of the other angle. So guys, if it helps, you remember rays start in a point and they go like this. They're opposites of each other. If for some reason you're having a hard time with the rays, think about it this way. For a vertical angle to exist, they have to share these two lines, right? So vertical angles will be 2 and 4.
Where's KB at?
Or 1 and 3. So therefore, angle 1 and 3 are vertical angles, and angle 2 and 4 are vertical angles. Vertical angles congruence theorem. So, the vertical angles are congruent. So angle 1 is congruent to angle 3. Again, the same ones we did before. And it's going to be angle 2 and angle 4 are congruent. This is a paragraph proof. So this is just an example. Again, this is just to show you what a proof looks like. We're not going to have these. So it says use the given paragraph proof to write a 2-column proof of the vertical angle congruence theorem. So given angle 5 and angle 7 are vertical angles, and they want us to prove that angle 5 is congruent to angle 7. So angle 5 and angle 7 are vertical angles formed by intersecting lines as shown in the diagram. So I'm going to highlight that so you guys see it. Angle 5 and angle 7 are vertical lines. You guys notice that there is right here, it's probably not the best color, and right there, 2, those are the intersecting lines. So as shown in the diagram, angle 5 and angle 6 are linear pairs. These two right here. Angle 6 and angle 7 are linear pairs too, so these two. Then, by the linear pair postulate, angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary. So by the congruence supplements theorem, angle 5 and angle 7 are congruent. So, prove vertical angles theorem. So angle 5 and angle 7 are vertical angles. They're telling us this is a given. 5 and 7 are vertical angles. And they wanted us to prove that angle 5 and angle 7 are congruent. Let's do this. The first statement is the given. So angle 5 and angle 7 are vertical angles. I'm going to write 1 is given. Now, number 2 is angle 5 and angle 6 are a linear pair. So 5 and 6 right here. And angle 6 and 7 are linear pairs. That is a definition of a linear pair that was in the 2 slides ago or 1 slide ago. I don't remember exactly. Now, step 3 is angle 5 and angle 6 are supplementary. And angle 6 and angle 7 are supplementary. Now, that is the linear pair postulate. And number 4 is that angle 5 is congruent to angle 7. So congruence supplement theorem. So I'm just going to do a little equal sign with the squiggly, which is the congruence sign. Supplement theorem. Example 6, they want us to find the value of x. Now, we know that angle, let's work on this one together. We know that angle TPS, so this one right here, is congruent to angle QPR, which is this one right here, because they are vertical angles. Now, since the measure of angle TPS equals the measure of angle QPR, we can say that 148 degrees equals 3x plus 1. Now, here is when we subtract the 1. So we're going to get 147 is equal to 3x. Then we're going to divide by 3 on both sides to get x. And we're going to get that x is equal to 49. So they want us to classify each statement as true or false for this example 7. So if the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, then angle A, B, and C are supplementary. Now this statement is false. It's false because you can only be 2 angles for it to be supplementary. So false because it can only be 2 angles.
Yes.
Now 2 vertical angles have the same measure. That one
True.
is true.
False.
And then lastly, if angle 1 and angle 2 are vertical angles, the
False.
measure of angle 1 equals 2x plus 8, and the extra measure of angle 2 equals 3x plus 14. Then x equals to 14. The way you will figure this out is actually just equal them out, and let's solve for x. I'm going to subtract the 2x on this side, and I'm going to get 8 is equal to x plus 4. I'm going to subtract it on both sides, and I'm going to get that 4 is x. So obviously it's not x is equal to 14, so it is false. You guys can go ahead and go to Big Ideas and do your homework. This is due on Monday.